So here's the implementation of our remove method. However, there is a tiny issue in these two methods, is valid parent and larger child index. Let's talk about them one by one. So in this method, we have a simple expression to return the index of the larger child. However, it is possible that a node doesn't have any children, or it might have only a left child. So we need to handle these scenarios here. How do we know if a node has a left or a right child? That is very easy. We get the index of the left child or the right child and make sure this value is less than or equal to the number of items in the heap. So it's a valid index. So I'm going to create another helper method, private boolean, has left child. We give it this index, and here we return left child index is less than or equal to the size. Now I'm going to duplicate this and create another helper method, has right child, and here we call the other helper method. Okay, now back to our larger child index method. First, we check to see if we have a left child here. If we don't have a left child, that means this node doesn't have any children because we always fill our nodes from left to the right. Okay, so if we don't have a left child, we simply return the same index. Next, we check to see if we have a right child. If we don't have a right child, that means the left child is the greater one. So we simply return that value. So if we don't have a right child, we return the index of the left child. Okay. Now you might be wondering why I'm doing this. Because our array of items is initialized with zeros. So we cannot rely on this expression to determine the index of the larger child. So if we don't have a right child, we simply return the index of the left child. Otherwise, we compare the left and right children and return the index of the larger child. Okay. Now let's look at the isValidParent method. Again, we are assuming that this node has two children, left and right. We should expand this logic and count for scenarios where a node has no children or only the left child. So if we don't have a left child, that means this node is valid. So we return true. Next, we check to see if we have a right child. If we don't have a right child, we just want to make sure that the value of this node is greater than or equal to its left child. So if we don't have a right child, then we return the value of this expression over here. Otherwise, if we get to this point, that means this node has two children. So we should make sure that the value of this node is greater than both its children. Now we have a bit of duplication here. We have repeated this expression in two places. So let's restructure this code. If this condition is false, that means we do have a left child. So the value of the current node should definitely be greater than or equal to its left child. So here we declare a variable isValid and move this expression over here. Now, I'm going to reverse this condition. So if you have a right child, we want to make sure that the value of the current node is also greater than or equal to its right child. So here we said isValid to isValid and here we use the second expression. Okay. And finally, we simply return the value of the isValid variable. Now here we can simplify this expression by using an augmented assignment operator. That's better. So these are the edge cases that you had to count for. If you didn't, that's perfectly fine. Remember, you are a student, you're learning. So it's okay to make mistakes. Now let's test our implementation. So back to the main class. Let's remove the root node, which is going to be 22. So heap.remove. After this operation, 17, which is the largest value, should be moved to the root node. So let's run the program using the debugger. So we have 17 at the root. On the left, we have 5. On the right, we have 10. Both these values are smaller than the root. And this 4 that we have here is the left child of 5. Now here we have another 5. That is the 5 that we moved to the root node before we started the bubbling down operation. But if you look at the size of this heap, you can see that this 5 is not included in the heap. So the size should be 4 because we have 4 items in this heap. There you go. So our heap is working properly. Now, back to our remove method. I'm going to change the return type of this method to int so we can return the value that we just removed. So before we reset the root, we're going to copy what we have in the root node into a variable called root. And then at the end, we simply return the root. Now, our remove method is getting a little bit bulky. I would prefer to extract these few lines into a separate method called bubble down. So, real quick, private void bubble down. Now, we grab these few lines and move them down into our new method. And finally, we call this method in our remove method. That is much better. So we're done with the implementation of our heap class. Next, I'm going to show you how we can use heaps to sort data.